An equilateral triangle with side lengths is inscribed in a circle. Okay, so important here. Well, okay, so it's inscribed in a circle. And this would be 60 degrees, this is 60, and this is 60. And it's asking me what the radius is. So very important when you have an equilateral triangle that's inscribed in a circle, the when this is not the radius, like this is not the center and this isn't the radius. So in order to really properly get what the radius is, you have to know this fact, which is that the center and the radius, they extend to each of the vertices of the triangle. So this would be the radius, this would be the radius, and this would also be the radius. Okay, but this is not the radius, this blue line here. However, we can see that when I cut this triangle, whenever you cut the equilateral triangle in half, it creates two 30, 60, 90 triangles. So first I'm going to deal with this one. Remember it said that the side lengths is k for each of them. So this would be k over 2, and this would be k over 2, these two sides here. Okay. So I have k divided by 2, and then this would be k divided by 2 root 3. Why? Because those are the side proportions of a 30, 60, 90 triangle. And friendly reminder, this is given to you on your formula sheet, but it's good to know anyways, as you see, because I'm solving it so quickly with my knowledge. It's always x root 3, 2x. Okay, so next, if I want to get the radius, we can see this triangle here actually creates another 30, 60, 90 triangle. So I'm going to make this my pink little triangle. However, the 30 degrees is here and 60 is here, which means that the k root 2 is now equal to x root 3. So if I wanted to solve for x, what I have to do is do k divided by 2 divided by root 3. And when you do that, trying to make this like as clean as possible so that everyone understands, but I'm dividing by root 3. So if I'm dividing by root 3, this would be, let me put in black, k over 2 times, so since I'm dividing by root 3, I'm going to multiply by the reciprocal of root 3, which would be basically 1 over root 3. So k over 2 root 3 is equal to x. Okay, so that's what this is. And then we want the radius, which is 2x, which corresponds here to the radius. So this is going to be 2 times k over 2 root 3, which is 2k over 2 root 3. However, you want to get rid of the square root in the denominator. So to do that, we would multiply both the top and bottom by root 3. This is called rationalizing out the denominator. So I would have 2k root 3 over 6. Why? Because this would be 2 times 3, which is 6. And then I can also see that's still not an answer choice, but if I simplify that, divide everything by 2, this becomes k root 3 over 3. And that would be our correct answer. That one's definitely a doozy, but the main takeaway for this problem is that Whenever you cut an equilateral triangle in half, it creates two 30, 60, 90 triangles. If you have an equilateral triangle that's inscribed in a circle, the radius is always going to be when you extend from the center to each of the vertices. And then creating that, you see that we have another 30, 60, 90 triangle. Hi guys, I'm Jackie. Thank you so much for watching this video. Please be sure to like, comment, rate, and subscribe if you like this video and you want to keep getting more amazing SAT questions. Thank you again and have an amazing day.